The centroid of a triangle. Special type of line that can be drawn in a triangle is what's called a median. So if we work from a vertex and we draw a line that connects to the midpoint of the opposite side, we will have just drawn what is referred to as a median. There are 3 medians to every triangle, and you'll notice that they all intersect in the same point, or at the same spot. That location is what is referred to as the centroid. So we'll draw these tick marks to indicate that those points are midpoints, and we'll label some of the locations that are created, like the vertex, the midpoints, and the centroid itself. So our centroid is this point G. Now, centroid is also referred to as the point of balance. So if you were to cut out a triangle of any shape, if you were to locate the centroid, in theory, you would be able to balance that triangle at that point, say on a pen or a pencil or something that would hold up that triangle. If you put it underneath the centroid, it should not tip, in theory. So point of balance is what the centroid represents. Now, there are some distances and relationships that are formed between a vertex, a centroid, and the midpoint. So let's look at median AF. What we know about the centroid is that the distance from vertex to centroid, AG, will be equal to 2/3 the length of the entire median. So that's the first thing we know based on that centroid theorem. Now, if we know that, then we can derive some other pieces of information that may be useful in problem solving. If we know that AG, so from vertex to centroid, is 2/3 of the length of the median, then we also know that the other piece, GF, must be 1/3 the length of the median. And from these two facts, we can see that AG must be therefore 2 times the length of GF. Or another way to interpret that is that GF would be half the length of AG. So knowing these things would be a useful tool in a problem-solving question related to lengths of segments when we have a centroid available to us. So those are some distance relationships with a centroid. Now let's look at how we would calculate the location of the centroid if we were given the location for 3 coordinates. So the example 3 coordinates we will look at are 8, -1, 2, 7, and 5, -3. Let's plot these points. So we have X, we have Y, and we have Z. Now, because the centroid is the point of balance, we also know that the centroid will always be on the interior of the triangle. You're not going to have a point of balance on the exterior of a triangle. So how do we get this? Well, we know because it's a point of balance, it's going to end up being the average of all the X values in our 3 coordinates and the average of all the Y values. Another way we could find it is if we wrote the equation of the medians and find out where they intersect. And to write the equation of the medians, we could just say, we know they're supposed to intersect the midpoints of the opposite side from the vertex that we're originating from. So if I know that, then I can find the slope of the median. I know a point it passes through, whether I choose the original vertex or I choose the midpoint. And then I can do that for 2 of the 3 medians, figure out where they intersect, and there's my centroid. Now, that's a labor-intensive path to finding the centroid when we have this other tool where we could just average the X and Y coordinates. So when we average the X coordinates, think the X coordinate tells you the horizontal distance traveled from the Y-axis. So we can draw some lines here. Think if I took those three blue lines that I drew that represent the distance traveled for the x-coordinate of each point, and we put them end to end, we divided them by 3, the length of that new segment, after I've divided it into 3 equal parts, would give me the location or the distance from the y-axis that I should travel for the centroid. We can do the same thing for the y-coordinates, where the y-coordinate will tell you the distance traveled from the x-axis. And we're going to account for sign as well. So if it's below, we're going to do negative. So think of the sign just telling you direction, right? If we put these end to end, where if they're negative, we're actually going to have to subtract that little length, where the other 3 were positive, so we just put them end to end. But these two negative, and then we're going to have to subtract that from the other length. And then we divide that little piece into 3. That will tell us where we need to go in terms of a y-coordinate. So let's just make a note that these are negative. This one's positive. And then the other 3 were positive because they're going to the right. So in general, let's write a formula for a centroid. We average the x's, and we average the y's. This is the quickest pathway. Otherwise, we would have to write the actual equations for the medians. So let's do that. So let's calculate this centroid. In this case, it's going to equal 8 plus 2 plus 5 divided by 3, and then negative 1 plus 7 minus 3 divided by 3. So what do we have here? We're going to have 15 over 3, which is 5. And then we're going to have 3 over 3, which is 1. So 5, 1. If I were to plot 5, 1, and let's actually connect these vertices so that we can see the triangle that's formed. If we plot 5, 1, does that look like it would be at a point of balance? So if we go to 5, 1, there's its location. And that looks like, first of all, it's on the interior of the triangle, so that's a good first sign. And then it looks like that's where I could balance that triangle out. So there's your centroid. There's the formula for how to find one when you're given 3 endpoints. And then we started the video with some distance relationships that you should be aware of for problem-solving applications in relation to the centroid.